And now we are discussing about liquid crystal display. These LCD displays we observe on the TVs, in the TV monitors, television monitors, and on the computer monitors, in our smartphone monitors, digital clocks, and in railway stations also we observe the LCD display. There you can see the train information. Similarly in aviation, in aeroplanes, wherever the information has to be displayed, we can use the liquid crystal display. Actually, this liquid crystal display, it is a passive display device. It cannot emit the light like LED. It is not generating the light, but it can only control the light. It requires an external light source like LED. This external light source supplies light to the LCD. LCD can control that light. Liquid crystal material is as the name itself it is suggesting, it is a liquid material. But we are saying liquid crystal. Crystal is solid. Because it is having the properties of the solid, we are calling this as a liquid crystal. Those materials are pneumatic or cholesteric. These are the special type of materials. In normal liquid, the molecules are oriented in random directions. But in these materials, pneumatic and cholesteric, the molecules are oriented in a particular definite pattern, like solid. That's why we are choosing these materials to display the information, whether that is a text or image or audio or video. We want to see some video information or text information, or we want to edit some audio files on the screen. LCD display will be very much useful to us to see this information. Generally, based on the working principle, LCD is classified into two types. One is dynamic scattering type, second one is field effect type. In the dynamic scattering type, we are using the two glass plates, and this is the LCD material, either pneumatic or cholesteric. When the light is falling on this glass plate, because it is transparent, it will go to the LCD material. If the electric field is applied to this material, then all molecules will be oriented perpendicular to that electric field direction. When all molecules are oriented to a particular direction perpendicular to the applied electric field, the light will be scattered. That's why, and the screen is appearing like brighter. That's why we are calling this as a dynamic scattering type. In the second, when the electric field not applied, this will appear like transparent. The light will go through it like glass. When electric field is applied, the light will be scattered along this material. And the next one is field effect type. In this field effect type, we are taking the LCD material and we are also taking two glass plates. Along with these two glass plates, we are also taking two filters, two optical filters. One is horizontal optical filter, second one is the vertical optical filter. When the horizontal polarized light is going through this horizontal optical filter, it will allow. But the vertically polarized light will not be allowed by the horizontal optical filter. If this light is going through this LCD material, when the electric field is applied, this light will twist. This light will be twisted by this LCD material. The twisted light orientation is now vertical, and this vertical optical filter will allow that one. In the normal time, when the horizontally polarized light is going through this, if the electric field is not applied, it will not twist and the light will not go through the optical filter. This is how field effect type is working. We have seen the different applications of the LCD display. In all these applications, we are using this as a display Passive display device. Background, we supply the display by using the LED. All these cameras, in the cameras also we are using the LCD display. In the digital signage, in the medical department, for the monitoring the patient vital levels. For all the display devices, we can use the LCD.